So in the last class we saw that there are two types of physical quantities, scalar quantities and vector quantities. Okay. So scalar quantities are the quantities which have only magnitude and no direction, and vectors have magnitude as well as direction. And to represent vectors we draw arrows in space. Okay. The length of that arrow represents the magnitude and the tip of the arrow represents the direction. Then we also saw the law for addition of two vectors. So suppose a bar and b bar are two vectors, then the resultant is given by this vector. So this is called as triangle law or parallelogram law of vectors addition. So if a bar and b bar are two vectors represented by two sides of a parallelogram taken in an order meaning second vector starts at the point where first vector ends. Then the resultant is represented by the third side of that triangle. This is triangle law, and if we recall the parallelogram law, then it says that if a bar and b bar are two vectors represented by two sides of a parallelogram starting at the same point, then the resultant, that means result of addition of those two vectors, is represented by the diagonal of parallelogram starting at the same point. Then we derived the derivation for the magnitude and direction of that resultant. So we found that the formula for magnitude is magnitude of the resultant is equal to square root of a square plus b square. So magnitude of first vector square plus magnitude of second vector square plus 2 times of magnitude of first vector multiplied by magnitude of second vector multiplied by cosine of the angle between them. Okay. And we also found the angle the resultant vector makes with one of these vectors, let's say a bar. So suppose angle is alpha and angle between a bar and b bar is theta, then alpha is given by tan inverse of b sine theta. So b I'm sorry, so b is magnitude of second vector, tan inverse of b sine theta divided by a plus b cos of theta. Okay. So now we'll talk about the sine law. So now let's consider this triangle CEM. Okay. In triangle CEM, I have sine of alpha, sine of this angle alpha as this opposite side EM divided by hypotenuse. Okay. So in triangle CEM, I have sine alpha equals to length of this side EM divided by length of this side CE. So EM divided by CE. Okay. So length of side CE is equal to R. So what I can say is sine of alpha is EM divided by R. And therefore I can write that EM is equal to R multiplied by sine of alpha. Okay, if I take R on other side, then I get EM equals to R multiplied by sine of alpha. So suppose this is my equation number 1. Okay, then now let's consider this triangle EDM. Okay, so in triangle EDM, I can say sine of theta, sine of this angle theta is equal to EM divided by length of this side. Okay, so in triangle EDM, I have sine theta equals to EM divided by DE. Okay, and length of this side DE is magnitude of B bar. So we have EM divided by DE, and that is equal to EM divided by magnitude of vector B bar, that's B. So I can rearrange this also. So I can take B on other side. So from this equation I get EM equals to B multiplied by sine of theta. So EM equals to B multiplied by sine of theta. This is my equation number 2. And now if we compare equation 1 with equation 2, then left hand side of equation 1 and equation 2 are identical. That means right hand sides should be equal to. Okay. So I can write that R sine alpha equals to B sine theta. Okay. So comparing equation 1 with 2, we get R sine alpha equals to B multiplied by sine of theta. And if I take this sine theta on left hand side, it goes into the denominator. Sine alpha on right hand side, it also goes to the denominator. So rearranging this, I can write as R divided by sine of theta is equal to B divided by sine of alpha. And let's call this equation number A. Okay. So in equation A, we related vector R, the magnitude of vector R and magnitude of vector B with these angles theta and angle alpha. Now let's suppose this vector B makes an angle beta with R bar. Okay. So suppose this angle over here is beta. Okay. Then I will do a substitution. So I will draw a perpendicular starting from this point D on this side CE. Okay. And suppose it meets at some point, let's call it point N. Okay. So now let's consider these triangles CDN and triangle EDN. Okay, and let's find out sine of alpha and sine of beta. So here we notice that opposite side for both these angles is same, it's side DN. So if we compare sine of alpha with sine of beta, we'll get some relation. Okay, so let's proceed. So in triangle CDN, sine of alpha, sine of alpha is equal to length of this opposite side divided by length of this hypotenuse. So it is dn divided by CD, and length of side CD is magnitude of vector A bar. Okay. So this is dn divided by magnitude of A bar, which is A. So I can rewrite this as dn is equal to A multiplied by sine of alpha. Okay. So I get dn equals to A multiplied by sine of alpha. So let's call this equation number 3. And after that, let's consider this triangle. So in this triangle, we have sine of this angle beta is equal to this opposite side dn divided by length of the hypotenuse, which is d. Okay, and that's magnitude of vector B bar. So in triangle DEN in triangle DEN, we have sine of beta equals to dn divided by de, dn divided by de, and that is dn divided by b. Okay, and from this equation we can write dn equals to b multiplied by sine of beta. So this is our equation number 4. Now let's compare 3 and 4. So let's compare equations 3 and 4. So comparing equation 3 and 4, we have, since left hand sides are equal, they are dn. Right hand sides should also be equal. So we have a sine alpha equals to b sine beta. Okay. So we have a sine alpha equals to b multiplied by sine of beta, and then I can rearrange this and write as a divided by sine beta equals to b divided by sine of alpha. Okay, and let's call this equation number b. So now let's compare a and b. So this is laying the derivation. Okay, in equation number a, we have r divided by sine theta is equal to b divided by sine of alpha, and in equation b also we have b divided by sine of alpha, it is equal to a divided by sine of beta. So comparing a and b, what we can say is r divided by sine theta equals to b divided by sine alpha, and that is equal to a divided by sine of beta. Okay, so let's write that. So comparing a and b, equation a and equation b, we have r divided by sine theta equals to a divided by sine beta, and that is equal to b divided by sine alpha. And this equation that we got after a long derivation is known as sine law. Okay, so this is known as sine law in a triangle or sine law for vectors. Okay, so law of sines for vectors. So let's see what does this mean. So r divided by sine theta, let's go back to the diagram. Okay, so here is our diagram, r divided by sine theta. Okay, and what's theta? So theta is the angle between other two vectors a bar and b bar. Okay, so magnitude of one vector, which is resultant in this case, divided by sine of the angle between other two vectors is equal to magnitude of, let's say, a bar, okay, divided by sine of the angle between the other two vectors r and b. So it is equal to magnitude of b bar divided by sine of the angle between other two vectors. Okay, so this is how we can memorize it. So what does this mean is, this means magnitude of r divided by sine of the angle between other two vectors equals to magnitude of a divided by sine of angle between r and r and b, and that's equal to b divided by sine of the angle between the other two vectors.